Imagine our world transformed. What if our eyes possessed a new power? A power to see beyond what we know? What if every single kind of light became visible? Our homes would suddenly look alien. The sky would become an unfamiliar canvas. Every leaf, every stone, every face would tell new stories. The universe is awash with light. Yet most of this light remains invisible to us. We are like sailors on a vast cosmic ocean. We can only perceive a tiny sunlit patch of water. The immense depths, the hidden currents, elude our natural senses. This unseen light carries information, vital clues about the cosmos. It reveals the very fabric of reality. If we could suddenly see all of it, our world would shift. Familiar landscapes would become breathtakingly new. So let us journey across the entire spectrum of light, to witness the universe in its complete radiant glory. Our eyes are truly remarkable instruments. They grant us the gift of sight. They show us the beauty of a sunset. They paint our everyday world with a rich palette of colors. We see red, orange, yellow, green, blue, indigo, and violet. This band of colors is what we call visible light. It is the light that shapes our direct experience of the universe. But this visible light is merely a sliver. The complete range of light is known as the electromagnetic spectrum. This spectrum is incredibly vast. It stretches from very long waves to incredibly short ones. Our human vision is confined to a small segment in the middle. Think of an immense piano keyboard. Our visible light is like one single key, just one note in an enormous cosmic symphony. So much of the universe's song remains unheard by us. This inherent limitation profoundly shapes our understanding. It defines what we consider to be normal. Beyond the confines of our limited human senses, a richer reality awaits discovery. Just beyond the red light that our eyes can detect lies infrared light. The term infrared simply means below red. We cannot see this light with our naked eyes. However, we can certainly feel it. We experience infrared radiation as heat. The comforting warmth emanating from a campfire is infrared light. The sun's rays warming your skin carry infrared energy. If our eyes could perceive infrared light, our world would shimmer. Warm objects would glow with an inner light. People and animals would radiate their body heat, appearing luminous. Even the night would never be truly dark. Residual heat in the ground, in buildings, would paint a ghostly landscape. Interestingly, some creatures in nature can see in infrared. Certain snakes, like pit vipers, possess this ability. They use it as a secret weapon to hunt warm-blooded prey, even in complete darkness. Technology also allows us to harness infrared vision. Night vision goggles work by detecting and amplifying infrared light. Firefighters use infrared cameras to navigate smoke-filled buildings. Doctors can use thermal imaging to observe blood flow patterns. Infrared light, though unseen by us directly, provides powerful tools. At the other end of our familiar rainbow, beyond violet light, lies ultraviolet light. As infrared means below red, ultraviolet or UV means beyond violet. UV light carries more energy per photon than visible light. While some UV is beneficial, too much exposure can be harmful. We know this from painful sunburns. If we could see into the ultraviolet spectrum, the world would appear dramatically different. Many flowers possess intricate patterns visible only in UV light. These patterns are invisible to us, but for bees they act like bright landing strips. Bees can see UV light. For them, flowers are not just colorful but also have these secret guiding signals. Some birds and insects also perceive ultraviolet light. This ability can help birds find ripe fruits. UV patterns on feathers can also make birds appear more vibrant to each other. The natural world is teeming with UV signals. Ultraviolet light also has practical applications for us. It can be used to sterilize equipment by killing germs. Forensic scientists use UV light to reveal hidden evidence. Our eyes, however, are naturally protected, blocking most UV radiation. Beyond the energetic ultraviolet waves, we encounter even more powerful forms of light. X-rays are next on this cosmic scale. We are most familiar with X-rays from medical examinations. They have the remarkable ability to pass through soft tissues, but they are absorbed or scattered by denser materials like bones. This property allows doctors to peer inside our bodies without surgery. Imagine possessing X-ray vision. People around you would appear as walking skeletons. Buildings would seem transparent in a different way. You could see their inner steel frameworks, their pipes, their wiring. Gamma rays are even more energetic and penetrating than X-rays. These are the most powerful waves in the electromagnetic spectrum. They are produced by some of the most violent events in the universe. Think of nuclear reactions, exploding stars, or distant quasars. Gamma rays are highly dangerous to living organisms. They can deeply penetrate tissues and cause significant damage to our cells and DNA. If our eyes could detect gamma rays, the experience would be overwhelming. Fortunately, Earth's atmosphere acts as a shield. It absorbs most of these harmful rays from space. On the other side of infrared, with much longer wavelengths, we find microwaves. And beyond microwaves, we enter the realm of radio waves. These waves have the longest wavelengths in the entire electromagnetic spectrum. They carry much less energy per individual photon compared to visible light or X-rays, but like all forms of light, they travel at the same cosmic speed limit and can journey vast distances. They are all around us all the time. If our eyes could perceive radio waves, our world would be a vibrant mesh, a complex, ever-shifting network of invisible signals made visible. Wi-Fi signals would appear as glowing clouds or streams. Radio and television broadcasts would fill the air with their patterns. Your mobile phone would pulse and shimmer as it communicates. Military radar, air traffic control, all would paint the sky. Our technology, of course, sees radio waves very effectively. Radio telescopes are our giant eyes on the radio universe. They allow astronomers to study celestial objects that are invisible in optical light. They can see vast, cold clouds of gas and dust between stars. These are the nurseries where new stars are born. They even detect the faint afterglow of the Big Bang itself. Our biological eyes are simply not built to detect radio waves, but our ingenious minds found a way. We built tools to unveil this hidden cosmos. What if we could perceive it all? Every single wavelength, from the longest radio waves to the shortest gamma rays. Would this expanded vision be a wondrous gift, or could it become an unbearable burden? Our brains would face an immense task. They would need to process this torrent of new information, all at once from every direction. Imagine the sheer cacophony of simultaneous signals, heat signatures from infrared, glowing everywhere, all the time, intricate ultraviolet patterns shimmering on every surface, X-rays revealing the skeletons and inner workings of everything around us, radio waves painting the air with a dense web of communications, and high-energy gamma-ray flashes from deep space piercing through it all. It sounds less like clear vision, more like sensory chaos. Our brains are remarkably adept at filtering information. They constantly sift through sensory input. They help us ignore unimportant background sounds. They allow us to focus our visual attention on what matters, but this comprehensive, full-spectrum vision would present an unprecedented challenge. Perhaps we would be utterly overwhelmed. The world might become a bewildering, unnavigable storm of light. Our vision, like all our biological traits, is a product of evolution. It was meticulously shaped over millions and millions of years. It was sculpted by the specific conditions of Earth's environment. Our star, the Sun, emits a significant portion of its energy as visible light. Crucially, Earth's atmosphere is transparent to these wavelengths. This is the light that was most abundantly available to life developing on the surface. Water also played a significant role in shaping our sight. Early life, including the ancestors of our eyes, evolved in aquatic environments. Visible light, particularly the blue-green part of the spectrum, penetrates water relatively well. Other wavelengths, like infrared or ultraviolet, are absorbed much more quickly. So, eyes naturally evolved to utilize this reliable window of available light. Furthermore, seeing too much could actually be a disadvantage. Constantly perceiving high-energy X-rays and gamma rays, for example, might be terrifying. Our current vision, by not seeing these, indirectly protects us. Therefore, our limited range of vision is not a defect. It is a finely tuned feature of our evolutionary heritage. It helps us thrive on planet Earth, and when we desire to see beyond these limits, we use our intelligence.